In this video, once again, we're going to look at graphing a rational function. This is the last one we're going to try, so we're going to do it step by step. As a reminder, to graph a rational function, first we identify any zeros of the denominator, and that will help us find the vertical asymptotes. Then we find any horizontal asymptotes or oblique asymptotes by using the rules above. Then we find zeros of the function by setting the numerator equal to 0. Then we find the y-intercept by substituting 0 in for the function. And then we find other function values to determine the general shape. Let's start this step by step by finding the zeros in the denominator. So in example 8, we have the function g of x equals x squared minus 1 over x squared plus x minus 6. I like to start by factoring both the numerator and denominator to see if they have anything that cancels. So if we factor both the numerator and denominator, x squared minus 1 is the difference of two perfect squares, and we'll factor 2x plus 1 times x minus 1. In my denominator, we have x squared plus x minus 6. Here we try to think of two numbers that will multiply together to give us that negative 6 and add together to give us a positive 1. In this case, that would be x minus 3 times, x plus 3 times x minus 2. They multiply together to give us 6 and add together to give us 1. So that's the correct factor. That will help us in our first step where we find the vertical asymptote. So remember above, to find the vertical asymptote, set that numerator equal to 0, or I'm sorry, denominator equal to 0 to find those. So for our vertical asymptotes, we get x equals negative 3 and x equals 2. Because we set each of these factors equal to 0, subtracted the 3 and added the 2 to get those. And here's the graph of those vertical asymptotes. That will help us guide us as we try to graph our rational function. The next thing we do is that we look for our horizontal asymptote. Now, in order to do that, we look at the rule that involves the degree of the numerator and the degree of the denominator. So what the rule said is if the degree of the numerator and the degree of the denominator were the same, then as they are here, then the horizontal asymptote is y equals 0. Because our degree here was 2 and in the denominator was 2, so they were the same. So the horizontal asymptote is y equals 0, which is the x-axis. Go ahead and graph that. The next thing we're going to look at the x-intercepts, which are also called the zeros of the function. Here. So the zeros are the same as the x-intercepts. And above, it told us the way we do that is we set the numerator equal to 0. So go ahead and do that, and let's identify those x-axis intercepts. Setting the numerator equal to 0 gives us x minus 1 equals 0, or the x plus 1 equals 0. Solving these, we get x equals 1 and x equals negative 1. So those are our x-axis intercept. Our y-axis intercept are found when we substitute 0 into the function. So our y-intercept will be when you substitute 0 in. Let's see what you get for that. Substituting in 0, you'll get 0 squared minus 1 over 0 squared plus 0 minus 6. So that leaves us with a negative 1 over negative 6. The negatives cancel, giving us positive 1/6 is y. So our y-intercept is 0, 1/6. All right, now let's see if we can graph part of this. I don't know what's going on to the left of my x equals negative 3 vertical asymptote, or what is going on to the right of x equals 2. But I do know that these are my only x-intercepts. So this curve is not going to come back up and do that. It's not going to cross the x-axis again because we already found our x-intercepts. So what has to happen is that this looks like kind of like a negative, a parabola that opens downward. This is going to do this. It's not going to cross the x-axis again, and that. We know that must be the case. But we don't know what's going to happen to the left of negative 3 or to the right of 2. So this is where we substitute points in. Maybe we'll substitute a point in back here like -4. So go ahead and find g of -4. Let's see what that gives us. Substituting in a -4, we get 5/2, which is the same as 2.5. So here's that point here when x is -4 and y is 2.5. Now that we know that it is above the x-axis, it's not going to cross the x-axis again because we only have these as our x-intercepts. So, and it's not going to cross the vertical asymptote, so it's not going to come back down and do that. It's got to do this, and it's got to do this. Let's try a number to the right of 2. Maybe try g of 3 to find another point on our graph. When we substitute 3 in, we get 4/3 or 1.3. So here when x is 3, y is 1.3. Once again, we're not going to cross this vertical asymptote and we're not going to cross the x-axis again. So this function must do that. And that's how we graph rational functions. Thanks for watching.